right, we're now going to get into one of our last learning targets in our probability unit. The concept that we're going to talk about now is the idea of what a complement is in probability. And I kind of alluded to it earlier on in the video with independence and dependent probability, I believe. But the complement of an event is all the possible outcomes except for that event. So the complement of rolling a 1 on a dice is rolling a 2, a 3, a 4, a 5, or a 6. That's why the opposite of the probability of rolling a 1, 1, 6, the opposite is 5, 6, okay? So essentially it's when it's not happening. It's the opposite, okay? And our notation for it would be, if it's event A, the complement would be notated by just a little apostrophe right next to the A. That notates complement of A, okay? One of the most important complements for you to recognize is the at least one. Anytime you're asked to find the probability that at least this one little thing will happen, you're actually better off finding the probability of none, okay? The official complement of at least one is none. So the official opposite, essentially, of at least one thing happening is not a single thing happening, okay? For example, let's say I have 10 kids and I'm trying to find the probability of at least one of those child being Bob or Sue. It's better off for me sometimes to figure out the opposite, the none. What was the probability of it not happening? Because then what I could use is the rule of subtraction. The probability of that event A happening is 1, which essentially represents 100% probability, 100% chance. 1 minus the probability of it not happening. So 1 minus the complement of that event. It's kind of a shortcut, okay? All right, so we're actually now going to get into an example problem. So my example problem reads, Calvin and Phoebe are visiting the children's ward at the hospital. The probability that Calvin gets the mumps. So this is the probability that Calvin will get the mumps is 0.13. That can also be represented by 13%. So 0.13, that's probably Calvin will get the mumps. Yes, mumps. And the probability that Phoebe will get the mumps is 0.07 or 7%. Okay? And we have to find a couple probabilities. The first probability is what's the probability that both Calvin and Phoebe will get the mumps? Now I added in the word and. It actually just says what's the probability that both catch the mumps. But I'm interpreting that as both Calvin and Phoebe. Yes, Calvin and yes, Phoebe. And means multiply. So both, I'm really taking the probability of Calvin and multiplying it by the probability of Phoebe. So if I'm multiplying the probability that Calvin gets the mumps by the probability that Phoebe catches the mumps, so 0.13 times 0.07, that gets me 0.0091. Less than 1% of a chance that both of them will catch the mumps. Okay. B, my next part of this question. What is the probability that Calvin does not catch the mumps? This is where I'm going to use my rule of subtraction. Does not catch the mumps. Well, that's the opposite of him catching the mumps. So I can take 100% chance, which is a 1, minus the probability that he did catch the mumps. So minus 0.13. So the probability that Calvin will not catch the mumps is 0.87, so 87%. Notice that it completes a 100% chance. He does catch the mumps is 13%. He does not catch the mumps, that's 87%. They filled each other out. The next question asks, what's the chance that Phoebe will not catch the mumps? So then I can also just use my normal logic. The chance that Phoebe did catch the mumps was a 7% chance, which was designated by 0.07. So the chance that Phoebe does not catch the mumps is essentially the opposite of 0.07, so it's 0.93. or 93% chance. 7% and 93% will add up to 100%. So both the yes and the no will make a full round probability for Phoebe. Let's get into another possibility. What is the probability that both Calvin and Phoebe do not catch the mumps? So it's the opposite of Calvin catching the mumps, the complement, and the probability that Phoebe did not catch the mumps. Again, the complement. Well, we essentially solved for the complement in parts B and C. The probability that Calvin did not catch the mumps was 0.87. And, because both of them are not getting the mumps in this situation, and Phoebe not getting the mumps is 0.93. So I'm multiplying their probabilities to find out what's the chance that both of them do not catch the mumps. And that equals 0.8091. So an 80.91% chance of happening. Now part E, last part, it's the probability that at least one of them will catch the mumps. So something to recognize in this situation is at least one. So you're really looking at the chance that Calvin catches the mumps and Phoebe does not. Or Phoebe catches the mumps and Calvin does not. So rather than calculating both of those probabilities, we can remember the fact that at least one is the official complement of none. Well, in part D, we actually solved for the probability that no one caught the mumps. So that is our none. So if we're solving for at least one, we know that we're going to take 1 minus the probability of none, 0.8091, and we're going to get 0.1909. Again, this is using our rule of subtraction and recognizing the fact that at least one is the official complement of none. That's why I can subtract him and give him the opposite. Okay?